Welcome to Defin, episode number 42, The Meaning of Everything with Antonio, all the way from Portugal, which is from a tiny place called Sesimbra. Is that right?
That's correct, yes.
Perfect. So this is Vijay from Holland.
And Raymond from Belgium.
So let's get started. Welcome, Antonio.
Hey, it's very nice to be here.
Nice to meet you. Did you listen to any of our episodes?
I have,
Please confess.
actually, yes.
Oh.
I did. Not all of them. I have an entire backlog on my podcast application, but I did listen to, or I was thinking about this yesterday, and I think I've listened to a majority of the episodes.
Wow.
Which means more than 50%, I suppose.
Yeah.
Depends on how you define majority.
So you are
we'll
the
go
one
with 50%,
who's...
yeah. we maybe have to get some sort of electoral college going here.
So, let's get to the topics of the
Before
day.
we go with the topics, VJ, can we just do the quick Patreon thing?
Yes, please.
Because we said last week that we were going to try and shout out to all of the guys that are doing the Patreon with us. And we did a few call-outs last week, and I want to make a few more call-outs this week. Because it really is fantastic, that people are prepared to put, a few dollars or $1 every month into the pot. And so, we really appreciate it. So the people this month I'd like to say hello to and give a shout out to are Bork Dude, Mr. Michael Borkent, over there in Holland. Good friend of the show. Dieter Comandera, Dan Boykis, and Jürgen Hotzel. Okay, so thank you very much.
Thanks
we really
a lot.
appreciate it. We appreciate your support, and let's hope we can get from 42 to 69.
Yes.
I think you might be setting yourself up for failure if you keep saying all these foreign names yourself.
Oh wow! Okay.
Because or like I'm saying,
who should say them for me?
I don't know. Maybe patrons could record their names, so
Yeah, that'll be.
so they come
Oh, wow,
across
okay.
clear. Because
Well-
I'd probably butcher them myself too.
Yeah.
Is what I'm saying.
I think it's part of the deal. If you pay money, you get your name butchered on air. So.
Oh wow! Oh yeah. I mean that makes sense.
I mean, you're not paying anything, and you're getting your name butchered on air. So.
Okay, there goes, I think, two more patrons dropping off, I guess.
Yeah.
Screw this! We're out of here.
Why am I paying for this abuse? Anyway, but thanks a lot. And I think it's episode number 42. It's been a pretty good run so far, I think. I think I was just commenting before we recorded, we started like 1960s Batman, and then the show became darker and darker. And then we've been making, I don't know, hopefully this episode is going to bring joy again into closure, and hopefully not pushing away people into camel, if you know what I mean.
Oh my god! Yeah.
So let's get started.
I take that personally.
So Antonio, just can you give us your journey into closure?
Yeah. So I think I started doing closure back in 2013. I was working this. I think a lot of people have. It's not uncommon to hear a story like mine, I suppose. I was doing a Java enterprise corporate JavaScript job, and I was losing hope and thought there has to be something else out there that can make me regain hope for programming and I guess computers in general. And I was actually really, really amazed when I saw Clojure and its design principles. But I think right out of the bat, I was trying to get started with ClojureScript, actually before Clojure. And because the experience was, to get started with ClojureScript back then was so rough, especially for a beginner that had never touched the language. I had to go through. My path had to be through Clojure first, and then figure out how I would make ClojureScript work. Because it's interesting that I was actually more interested in ClojureScript then, but I just couldn't get it work.
And you're still the number 3 contributor in ClojureScript.
I have done a little bit of work, yeah.
Cool.
We'll come back to that. But what was your reason for favoring ClojureScript over Clojure, Antonio?
I suppose I was always a little bit more intrigued about how to put beautiful things on the web so that everybody can consume them. I think it's just a personal choice, because it was always before I knew how or I'm not claiming I'm an expert or anything, but before I knew how to make web pages or pretty things on the web, I was always intrigued on how can there be such amazing experiences today, and how do I get to the point where I can make them too, like how do I solve all these problems of synchronizing things from remote endpoints and putting them here in a way that's really nice for users to consume. And I suppose the seeing aspect of it was always what intrigued me the most.
What was your background then?
I'm just a computer science, computer engineering student. I think that was my first job out of college when I started looking into this.
Okay. But I think if you're interested in building stuff for web, I mean, usually you don't end up thinking that, okay, I'm going to pick the roughest possible experience and then start from there.
Well, I was already building stuff with JavaScript.
Yeah.
And I think I came to the conclusion that it was going to be kind of impossible for me to figure out how to build these nice experiences that I was seeing all over the place with JavaScript itself, and I needed something that I could keep in my head more easily than I was with JavaScript. And I suppose React wasn't out by then. It was, I think, early 2013. I think React came out later that year. Yeah. And it was mostly jQuery, Backbone, and what was it called? The IBM, I think, Dojo UI.
Yeah, Dojo. Something. Yeah. I think I did some work in Dojo, and then the Yahoo UI EXT, and then that turned into EXT.js and turned into Sencha, and it was like a mess, and and also Backbone and other crap. Okay, so maybe before we get into other libraries that you built, like Luma, for example, can you give us some idea about your contribution to ClojureScript and your impression of the language and your opinion about it? Yeah,
so I think I came to I didn't start contributing to the ClojureScript compiler right away. I think I really got interested in ClojureScript in 2015 when David Nolan started talking about OhmNext, and how he proposed to solve all the synchronization and data, I suppose data fetching, data loading aspects of UIs, and I think at that point I was just kind of obsessed of how does this thing work, and where's he getting all these ideas from? Because it can be a kind of overwhelming when David is on his I think he has this building modes when he's deep down, in the weeds, just building stuff, something that he's has this idea that he sees a way forward, but it's kind of hard for people outside to just like everything else to see what people have in their heads. And I think at that point I really got obsessed into trying to understand what he saw there, and so I think that's how I started contributing to the ClojureScript ecosystem, was through OhmNext. And building a lot of example UIs in OhmNext and see how all that worked. And then I think I kind of graduated to the ClojureScript compiler once I saw, I just want to help out and and saw some bugs that I thought were easy enough for a beginner to the code base to contribute to. And then my I suppose we can call it mission inside the ClojureScript code base was trying to bridge the gap between ClojureScript on its little own, like, really nice island and the rest of the ecosystem, be it either Clojure or the wider JavaScript or NPM world. And so I think I actually got started with bridging some gaps between the ClojureScript and Clojure languages in a way that, so I think ClojureScript didn't support something like rename in namespace declarations. It also didn't allow you to use some other interop things that Clojure had, and that just, and so I suppose that my first objective right out of the bat was making sure that the reader conditionals were increasingly less necessary. And then I got started of like, okay, so this was really fun, but I kind of lost some interest, and I didn't see the point of, I don't think I saw the point of doing it anymore. And then I started looking out further into the NPM and JavaScript ecosystem, and this was after Maria Geller made her contributions in her Google Summer Clojure project, where Google Summer Code, where she, because the Google Clojure compiler has support for parsing these JavaScript dependencies that are not exactly in the Google Clojure format and outputting a Google Clojure format for them. And we started looking into how we could make that support that was alpha at the time even better, and make it so that you could just npm install any library from and be able to consume it in ClojureScript too. And then a lot of my work was a lot of work that I was doing was with respect to npm dependencies and how to consume these dependencies that were not made for the Google Clojure compiler, and then just seamlessly interop with them in ClojureScript, just like if you were calling any ClojureScript namespace.
Yeah.
And that turned out to be really, really harder than we expected. And it's still not, there are still some rough edges.
But what were the challenges there?
And so I think the first one and the more obvious one is that JavaScript is a very dynamic language. And the way you write JavaScript for the Google Clojure compiler to consume, because the Google Clojure compiler is this whole program optimizer that needs to see all of it in order to make assumptions and optimize and aggressively inline stuff, and also remove code that is unused. For it to be able to do those kind of optimizations, it needs to know a lot about your program, and your JavaScript needs to be written in this very static manner, which I would argue is not how the majority of JavaScript developers structure their code. And so things like adding variables to a module exports at runtime is something that is impossible to consume, for example, in a Google Clojure, in a static analysis kind of way, which is basically what the Google Clojure compiler does. Yeah. And the way it transpiles, or I suppose that's a word, it transpiles the say a CommonJS module to a Google Clojure compiler module or a Google Clojure library module is by inspecting all the exports and their dependencies and outputting this static thing. But it doesn't really do any code evaluation there. Yeah. So things like that are very dynamic, such as adding variables at runtime, it can't do. I suppose it would be interesting, now that I think about it, to combine it with some kind of partial evaluator like Prepack. I'm not sure if you've heard of Prepack. Prepack is this tool by Facebook which tries to pick your, it gets your bundle and tries to partially evaluate some parts of it, such that when it outputs the resulting bundle, a lot of things are inline. So it can, for example, like unfold some for loops that are, or I guess the example that they have on their website is you have this Fibonacci function, and you call the Fibonacci with 5, and they just inline the number, I think 120 in your code. So what it's doing is partial evaluation. And I suppose this strategy could maybe be combined with the Google Closure compiler, so that they could figure out some by just evaluating the top level things of a module and figure out what does this export and how can we then compile it down to a Google Closure library format. But we're nowhere near that.
So before coming to Closure, so
yeah, I think
script.
I started. I went on a tangent right there. Yeah.
No. Don't worry about it. I mean, this entire podcast is a tangent. So, no. So before coming to Closure script, you said you were only working with Java. So is this your first functional Lisp or functional thing? Or?
Closure script was, or I suppose something that I deployed to production was my first contact with a functional language. I had done some OCaml, and we can come back to that in a second. I had done some OCaml in college. But at the time, and okay, so if we're going off on tangents, here's another one. And so the reason why I got back into OCaml was actually ReasonML, the project by Facebook.
Ah, that's a nice pun. You know,
it is. Yeah, it is. It is both a blessing and a curse. It's really easy to make some unintended puns with that name. But anyway, so I got back into OCaml because when I did it in college, I think you can say that my professor at the time made a really nice job to make sure that none of us would ever touch it again in the way that it was taught to us. And like everybody just hated the way how it was presented to us without any context. So I think that was my introduction to functional programming, actually.
But OCaml is a statically typed language, yes. Right? Yeah.
Yeah, I had never done any Lisp before encountering Closure.
Nice. So you said that. So after some time, you stopped, or you reduced your contribution to Closure script, and is it because of some other reasons, or you go moving on to that?
See what I was telling you about?
It's a dark night again.
We have to. Unfortunately, let's see. I don't know. There is a light at the end of the tunnel.
Yeah. So I think it came a point where I'm this huge nerd that's always looking for new and interesting stuff to learn. And at some point, I found out about ReasonML and how Facebook was trying to put I think you can call it a sugarcoat on OCaml with the Reason syntax. And this was even when I was contributing to ClojureScript compiler. But then again, is one of those things where if you live at the cutting edge of something, you have to expect to get broken tool chains and broken setups all the time. So at the time, I wasn't really ready to dive into Reason yet because everything was really a pain to set up.
But this is essentially your thing, right? I mean, the first time when you enter ClojureScript, it's like a shitty experience, and then you look for where else is there more shitty experience.
Where's something that's going to break my entire setup? And and I suppose I got really interested in the Reason and OCaml ecosystem there, because it was, for me, a new way to think about how do we structure, or how I structure my programs. In a statically typed, or not statically typed, because I had done Java and I guess Golang before in college, but a language with a strong type system that really tracks the entire flow of your program. And if you make a mistake over there, there's something that the compiler knows that you don't know or you hadn't realized yet that tells you, oh, well, you can't really make that change over here without changing it over there where you're using it. And that was kind of enlightening for me and why I started digging into even more.
But before even getting into the reasonML stuff, can you give us some behind the scenes stuff about Lumo and how it came to be?
Yeah, I'd love to. So, okay, so I suppose we can establish a timeline here. And
yes,
it's
the retelling of the history.
Exactly. And so the timeline of my experience with Clojure would go back to early 2013, as I mentioned before, and then I think I started contributing to OhmNext in maybe middle 2015, and also I think late 2015 I started contributing to Clojure compiler. ClojureScript compiler, and then and at the end of the summer of 2016, I had my master's thesis to write, and I was looking for other things to do because I really didn't want to do it. and basically that's how Lumo came to be.
Lumo was just a displacement behavior.
Oh, it was a whole exercise of procrastination.
How to avoid doing the important things.
Because Mike Fikes at the time, he had come up with Plunk, which predates Lumo by more than a couple months. And I started, something that also really interested me at the time was the optional self-hosting ability of the ClojureScript compiler, and the way that you could just run ClojureScript and compile it without the need for a JVM. Because knowing a little bit about the JavaScript ecosystem too, I knew that people were not keen on installing a JVM, and so if we're going to bring more people to ClojureScript, we had to provide an option for them to get started, or at least kind of a gateway drug to the JVM, which would be, I thought, and I still think it's a really viable alternative, getting through to ClojureScript through a completely self-hosted environment. And so I saw Plunk by Mike, and I was really fascinated how fast it could start up. And I was like, oh wow!
It was the startup wars, wasn't it?
It was. Yes, it was. It was the startup wars, because starting a Clojure REPL was, a bare Clojure REPL is like 1 second, and probably even more now with ClojureSpec, and starting up a line project at the time, I think it was like 6 seconds, just with the tooling and machinery that involved. And Plunk was like this, I think 600 millisecond startup time. I was fascinated on how fast you could have something that you could just type something into a REPL and so fast. And Mike, he was really clever and made some other optimizations where he would show you a prompt without without even having loaded all the compiler stuff. So you could
take it until load it.
Yeah, so you could just start typing, and the time that you took to write something and click enter to evaluate it was a time that the compiler was loading in the background.
Yeah.
And so I think at the time it was like, well, I really like I'm really experienced in the Node.js ecosystem, and Mike did this thing that runs on top of JavaScript core. What if we had something that ran on top of V8, the Google JavaScript engine, and Node.js, and that could have access to any package in the npm ecosystem, and because it's running in Node, we don't have the problem of consuming libraries and needing to convert them from the common JS module type to the Google Clojure library module type, because we're already self-hosting inside this Node environment, so everything is already understood, because we don't really need to ship a bundle to somewhere else. And another goal was also, well, how can I be faster than Plunk?
Of course.
And so I had a rough prototype, because getting started with the ClojureScript self-hosted compiler is incredibly easy. And David Nolan and Mike Fikes had put a bunch of examples out there that was, for me, that knew someone who knew ClojureScript at the time. It was easy for me to get started, and so I started looking into how I could make it work. And after, I think, a couple of days, I had a prototype running, but I had this compiled JavaScript bundle that I would run in Node, and I had to figure out, so how do I package this in a single binary executable that just like Plunk, so I can distribute it. And that's and I was still not happy with it, because it wasn't fast enough. It wasn't. So I think Plunk was, as I mentioned, 600 milliseconds, and I was at about 900 milliseconds startup time. And I was like, this is not good enough. I need to do better.
Yeah.
So Mike, actually, I think he deserves most of the credit for me being faster than Plunk, because he mentioned to me, well, if you're running on V8, there's this little known thing that is really cool about V8 that are startup snapshots. And so what startup snapshots are is, when you're compiling V8 and compiling Node.js, you can tell V8 to load this JavaScript file that you give it. It will load it in memory, deserialize the heap into a bytecode file, and include it as part of the binary. And whenever it starts up, it just needs to deserialize that bytecode into memory again. And you have the same state that you had when you loaded the file at compilation time.
Right.
So basically what happens when you start up Lumo is V8 behind the scenes is doing this deserialization of the heap. So you're not really parsing and executing any JavaScript, which made it at a time start up in like 150 milliseconds.
Wow.
And so then I was happy.
Super cool. But what is the next step? I mean,
before we go into that, though, just stick with them for a second, because I think you got some adoption for like scripting environments, didn't you? Because that's the other nice thing about things like Lumo and Plank, especially Lumo, I think, because it was the other thing I remember about Lumo, which was quite interesting, was the fact that you could run on Linux as well as Mac, and you could run on Windows.
Yes.
And so it was because you're following Node, essentially.
Yeah, exactly. So again,
I
I do not deserve any credit for any of that, because I'm just piggybacking on what Node.js does.
Well, you get credit for doing it. It's okay,
Yeah.
No, I mean,
of course.
It's incredible to me how we're always standing on top of the shoulders of giants, especially because V8 is this platform where billions and billions of dollars have been poured into.
Yeah.
And I can just take that, use it to make some people, like this niche crowd that is into weird Lisp languages, happy with something that is the result of billions of dollars. And I think that's why I'm saying, those people do deserve a lot of credit, because I just made it work with, this little bracket syntax that we like over here.
Yeah, but that's what you want. I mean, that. There was the whole point about JavaScript was, according to Rich, and I think in general everyone knows this, is that Java rocks, but JavaScript reaches. And so the fact that you made it reach, you made ClojureScript reach on a command line to different platforms was. I thought that was pretty important. That was pretty good.
Yeah, Windows support was actually, Windows support is generally something that is really hard for, or at least something that is disregarded for a lot of people and that are doing developer tooling. And Windows support was one of the goals. One of the primary goals for Lumo was, I'm not going to ship this until it works on Windows. And even though I'm not a Windows user myself, I still wanted people who are running Windows to have the option to have Lumo available to them. And so I think, how it goes. Whenever the 90% of the time is spent doing the last 10% of the work.
Yes.
And that was Windows support for Lumo.
Well, isn't it turning around the other way now though? Because
Let me just
go on. Yeah, sorry. I thought you were
say
done.
one more thing.
Yeah, please.
Which is I really need to publicly thank the Berlin Clojure user group, because that's where I initially announced Lumo. I contacted, I think, Paulus at the time, who was running the meetup, and I asked him, well, can I come speak? I have something really cool to show. I want to talk about self-hosted ClojureScript. So you're kind of really bearing the lead there, but it was a really cool day. I announced Lumo at the meetup, and it got incredible reception. And those people are really, really nice, and they're an incredible group of people. So, thanks.
Yeah, of course. I mean, we have, I think, highest following in Germany. So we are very popular there.
Oh.
Practically like big celebrities in Germany.
Wow.
Yeah. I mean, I was there a couple of weeks ago. I didn't get any paparazzi, but I'm suppose they're hiding somewhere. But
I see.
Sure. But anyway, it's really cool that I was actually asking about the future of Lumo. Like where do you see it? And maybe before even we get there, I think we kept talking about Lumo. What is the elevator pitch? What exactly is Lumo? Maybe just say like one thing about it.
So Lumo, the way I tell it is, because there's still one missing piece that I need to talk about. But the elevator pitch is basically Lumo is this this fast cross-platform ClojureScript environment that you can have like at your in a one click. It's one click away from you to install it and get ClojureScript running anywhere.
Yeah. So all you need to do is npm install Lumo.
I suppose -g Lumo -cljs and you're off to the races.
Awesome.
That's awesome. That's an awesome beginner experience. I mean, that's got to be said. That's
that was the goal. And also it's incredible how like you put something out there and then people start using it in all sorts of ways that you never anticipated. And so my friend Victor from Sweden, he's running this company called Pelaxa, and they're doing I really don't want to get this wrong. So I think they're doing a smart device for people who are chronically ill to take their medication, because if you've just come off of an organ transplant and you miss like 2 pills in a row, you might just reject the organ outright. And so they have this smart pillbox that is connected to your phone somehow, probably Bluetooth or Wi-Fi, I'm not sure. And you get a notification every time you got to take a pill. And so he mentioned to me that the way he was building the firmware for the smart pillbox was, I'm not sure if he's still using it, but initially he put a Lumo script, and that's how he was doing it. And I was like, that's amazing. And like, I never imagined that Lumo could be used for that. And other people are orchestrating CI builds with Lumo, and that's also really cool. And there's some more use cases that are also cool. So Juxt in London, they were developing this replacement for make and make files using ClojureScript. They call it Mach. And using Lumo.
Nice.
And so the missing piece that I was talking about that is and it's the reason why I describe Lumo as a ClojureScript environment and not just a REPL is because besides all the scripting abilities, it also this was the second step in. So after the what did you call it, the startup time wars? After that phase was done, I wanted to see if I could be the first tool to provide an actual ClojureScript compilation without the JVM. So one thing that I think I did. So Lumo was released in November 2016, and I think in February 2017 or March, I wrote a blog post about compiling ClojureScript projects without the JVM. and I basically re-implemented and then again, in the topic of standing on the shoulders of giants, the Google Closure compiler team used GWT, the Google Web Toolkit, to compile the Google Closure compiler, which is written in Java, and they compiled it to JavaScript, and they put a version of the Google Closure compiler on npm.
Oh.
And so once that was available, then I thought, I do think that we have 100% all the pieces that are necessary to make a ClojureScript workflow exclusively on Node without ever needing to start up a JVM. And I set out to do just that, and I accomplished that in, I think, as I said, I think February or March 2017, where you could have a ClojureScript project that is obviously self-hosted compatible, so you can't really use any JVM macro machinery. And you can compile that ClojureScript project and get a Google Closure compiler, advanced, optimized, aggressively inline bundle, just like you would with the JVM.
Wow.
And I thought at the time, well, this was really cool.
Yeah.
It is still.
Yeah.
Well, unfortunately, and I think as you might expect, a lot of people are not using that simply because most of the libraries out there, in one way or the other, use some JVM libraries in macros, even for ClojureScript. So the number of libraries that are self-hosted compatible are still, I think, in minority. So there might be people using it, and if you are, please reach out. I want to know about it. That I don't think I know anyone who's using Lumo to compile for this use case.
But is the macros or the macro support? Is the macro support the only missing piece that is going to stop people from not using this?
By macro support, I want to clarify that macros are still supported in self-hosted ClojureScript. You just cannot use any standard, Java standard libraries in macros, just like you would in ClojureScript. And I think taking a step back is macros in ClojureScript are defined in Clojure because the ClojureScript compiler is written in Clojure, and it expands your macros in Clojure as part of the analysis process. And so you can't use macros that take advantage of Java tooling and libraries in an environment where there is no JVM running.
Okay.
But you can still write macros in self-hosted ClojureScript. So that is one of the limitations. I suppose another one could be that while the JVM is optimized for throughput, you could say that generally JavaScript engines are optimized for latency and time to first execution or something. But but they might not be as fast, and they're generally not as fast as Java, simply because Java has all the information about types at compile time, so you can make all the necessary decisions. And the consequence of that is that compiling ClojureScript projects with Lumo, and especially with the Google Closure compiler on JavaScript, takes a longer time than compiling the same project on the JVM. So I've seen a very small project in compiling a very small project with advanced optimizations in Lumo take like 60 seconds, whereas it would take maybe 15 seconds in the JVM.
Okay. So what's next for Lumo?
So right now, I think a couple weeks ago, I released a version of Lumo that is up to date with the latest version of the ClojureScript compiler. So it's running the latest ClojureScript compiler, but I have officially stopped working on it, and I would love if people who want to see Lumo keep getting updated and squash some bugs that it certainly has.
Yeah.
To come forward and reach out to me and say that they want to be a maintainer, and I would gladly talk to them and coach them and mentor them through the Lumo code base and build process, because I have lost interest. For me, the things that I set out to do are done, which is the startup time in the ClojureScript compilation. And now anybody that would basically want to carry the flag forward, they're more I would be more than happy to welcome them into the project and help them do that. Yeah.
That's really good. I mean, you don't, just because you start an open source project doesn't mean it's saying you have to own it for life,
Yeah, exactly.
I certainly don't want to see it bad. I want people to keep using it.
Sure.
I'm just not going to be the one maintaining it anymore.
Yeah.
But how challenging is it to maintain it, or do you have like a kind of a vision or a roadmap for it in the next 6 months, 1 year, 2 years or so?
I do think it's been pretty stable since its beginning, and with the exception of the compilation workflow. So the last thing we were talking about, which was alpha for some time, and then Andrea Ricciardi and I made some more improvements to it, and I think it's now pretty stable. It might not be up to date with the latest ClojureScript compiler, or the way it does things. But other than that, for the workflows that people have been using Lumo for, it's been very, very stable. And so I think that the roadmap for that is just keeping up to date with ClojureScript, fixing some bugs which generally appear at the boundary of the interop with Node.js, and keeping also the Node.js version up to date so that people can use the latest Node.js features.
Yeah, makes sense. That's fantastic. So, so from Lumo to next step, where are you right now?
So right now I'm really interested in working with OCaml. I got into OCaml through the ReasonML project, and that's why I started and still contribute to the ReasonML parser and preprinter and the entire toolchain, even though I'm mostly using OCaml syntax nowadays. And the reason for that is because I see it as a really viable alternative to get people started into liking functional programming and strongly typed functional programming, which is something that I really have come to appreciate. And so that's the area where I'm most active now and more interested in.
So are you going to go work for Jane Street Consulting?
Well, you never know. I don't really see myself working for Jane Street, but who knows?
I'm just trying to think of any other company that
right. So I think
Facebook obviously are as well. Yeah,
I think Facebook is using OCaml a lot for their internal infrastructure. ReasonML is actually powering more than 80% of Messenger.com now.
Right. Okay.
On the front end.
Okay.
So if you're if you use Facebook and Messenger on the web, you're using an OCaml project.
Yeah. I mean, the thing I've found interesting about OCaml in the past few years, which makes me think it's a very interesting language as well, is the unikernel stuff that's been coming out of the Mirage project, and also was now in all the kind of native sort of Docker stuff. So what kind of use cases are you looking at the moment? Obviously we're talking about a big range of possibilities here. So what kind of things are you getting excited about with OCaml?
So the reason why I got into OCaml and I was trying it out for a little while, and then the thing that really got me hooked was that I saw in OCaml the thing that I saw in Clojure when I initially got started, which is it's a language that has been in which all the design decisions have been thought about and have been carefully considered for a long time. And I saw it as a really pragmatic language in terms of usability and the features that it provided and still does, in a way that I maybe this is ignorance from my part as well, but that I don't see in other languages currently. Maybe I'm just unaware of them. And that's really what got me hooked into OCaml. And then I started.
Did you compare it with Haskell or some other kind of classic MLs?
Yes,
or?
I did. And I was actually, before looking into OCaml, I started looking into Haskell, and I read the what is it? Learn You Haskell for Greater Good. I think that's how the book goes. And what the idea that I got from it was that it's 100%. Let's say the analogy that I like to use is Haskell is 100% language, whereas OCaml would be an 80% language. And what this means, or what I want to make it mean, is that Haskell doesn't allow you to do any side effects unless it can control it. You need to explicitly tell the compiler that ask for permission to do a side effect, and then thread all the side effects through the here it comes, the M word, through the IO monad.
Yes.
And whereas in OCaml, the category theory is still there, but you don't really refer to any of the concepts through the theoretical nomenclature, if you will. So you never say that, I'm using the
monad.
I'm using the whatever monad or the bind function in the monad or whatever.
Yeah.
And another thing that it gives you is the ability. So because it's a strictly evaluated language, as opposed to a lazily evaluated language like Haskell, OCaml lets you intermingle side effects with your code. And so you can just, in a regular function, you can just put a statement that is printing to the standard output, or you can write to a file or make a network request or what have you.
Yeah.
And so that still goes through the type system, right? So in a function that returns an integer, for example, you can't return a side effect, right? You can't print, you can't return console log or whatever in a function that's supposed to return an integer. But you can say that at the top of the function, you print to standard output, and then you return the integer. So it still goes through the type checker, but it allows you to have these escape hatches, which I think are not only necessary but mandatory in the ways that we need to structure our programs today.
So obviously, saying that comparing with the type system is a bit kind of a weird comparison, because you can't compare the same thing with Clojure. But if you pick the other parts of Clojure, for example, better way of the whole immutability or concurrency, those kind of things, and availability of the libraries. So how do you compare that with the OCaml language or ecosystem compared to Clojure?
Yeah, so I think they're both pragmatic in their own way, which is the conclusion that I came to. And so Clojure is really, really nice because, or the thing that since the beginning really amazed me and got me fascinated about Clojure was the possibility of describing your data through these built-in literals that are they're never changed, right? So if you have a vector with one element and you let air quotes here, but if you add one element to it, you're not really doing that. You're saying the result of this operation is a new data structure. That has all of these internal optimizations to make it share memory and all that, but it's a new thing, and that kind of a thing I don't think I had seen before, and really made me interested in the way I really wanted to write my programs like that, because I saw something really cool there, something that I had never thought about. And when and I would say that is the pragmatism that I'm talking about. And so when I found out about OCaml, it also lets you, it doesn't have built-in immutable data structure by default, but it does not. But it has a number of other things that I was looking for at the time. Because say in Clojure, I really got tired of writing my code, running it, and then it's like trying it out, and then it blew up in my face. Like, oh my God, I'm so dumb. I made a typo, or I cannot get this right. And in OCaml, I like the way of I like almost like having a little buddy, like touching me in the shoulder whenever I make a mistake, and like, hey, you can't really run this program without fixing this whole this thing right here, because I'm not allowed to segfault, or whatever the equivalent would be for front end, right? And so it really touches you. It pokes you in the shoulder and tells you, please go fix that mistake, or I will refuse to run. And for me, that was incredibly helpful, because I found out that the way the things that I want to program are not things that I can keep in my head at all times. And having something like just offloading all that work from my brain to the machine made me think of the problem that I was trying to solve, instead of worrying about making these mistakes and having all these cognitive overload of things that I need to get right. Not in terms of syntax, because you can argue Lisps don't have any syntax, but in terms of like what are the fields that the data structure have, or what can I put in this map, or how can I make this functional transformation operation over this data structure. And in OCaml, I'm finding that whenever I want to do that, I can just hover over any variable, and my editor will tell me these are the exact set. This is the exact set of fields that this data structure has, and these are the only operations that you're allowed to make on these data structures, and these are the only ways that you can transform these data structures, because you can't really access a field X in something that only has a Y. If that makes sense.
Yeah, I mean, but this is pretty much standard for all the static languages, right? I mean, you have to some extent Java, and I did a lot of Scala as well. I wrote a lot of Scala before.
I would say that Scala is also strongly typed, but not
Sure.
not
Yeah,
not
of
Java.
course. Yeah. Well, Java has a bit more static typing than Clojure, right? I mean, a bit more, so you have much more
Right, it is more
support
than
from the
Clojure.
IDE, for example, having the hovering shit or whatever.
Yeah, exactly.
So
the way I
point
would
that I
contrast that is that types in Golang or types in C or Java are there, and they're mandatory. It's mandatory that you write them down. They are there so that you can tell the compiler how to optimize the generated machine code for your use case. Whereas in OCaml or Haskell, you don't really need to write down your types. You can if you want. But the types are there for the compiler to help you structure your program. But so it's kind of a different, flow of information.
Yeah, exactly. So, and also the development experience is a bit different, right? Because in Clojure, in Lisp, you'll be more like rappelling constantly, and then trying to write one function and then get it run. That's running nice, and then move on to the next step. But in the case of Haskell or Scala, for example, that I'm used to a bit, it's like it's not the same experience. I mean, it's like the whole thing needs to compile or not.
Compile or what is it? Write, compile, run cycle.
Yeah, exactly.
And something that also annoyed me is and maybe this is going off on a tangent again, is Clojure's startup time, because the whole REPL thing is really, really cool I would argue that is really, it doesn't serve a lot of use cases, or at least it didn't serve mine. The way I generally write software is I'm constantly switching between Git branches. Because say I'm implementing this feature and then I hit a roadblock and I'm waiting on someone from the business side to give me an answer, and so I switch to another branch where I have another feature, and I found out that in my setup I couldn't really keep my REPL open at all times. So in Git branches where you say remove a file or you add a new file, and I think those are the most problematic cases. I would have to constantly
REPL,
keep restarting my REPL,
and
that also added a lot of overhead to my development, and I found out that those kinds of things that cause you to switch contexts are the things that are most unhelpful to your the development and to your process, or for my mental process at least.
And how about the libraries and the tools and ecosystem and deployment and debugging? Because we keep talking about language level stuff. Of course, I understand language is the baseline for everything, but most of the time the challenges are integrating with external system. Most of the time the challenges are how do I deploy this shit? How do I monitor this thing? Those kind of things. So how is that on the other side of the pond, so to speak?
Yeah. Oh yeah, right. So Ray was asking about unikernels and the deployment scenarios. That is also something that I am really fascinated by. I must say that I have only played with unikernels this one time and for a little bit, and I really didn't get it deployed to any hypervisor. I only got it running on my computer. I think unikernels are really cool, and they might be something in the future. They're just not there yet because the development overhead is still significant. Because
choosing the packages.
Exactly. Yes. So whenever you're deploying your say a server to a cloud provider, you can just use time in your logs or log to disk or have them send socket packets. Or send packets via a socket. And in a unikernel scenario, you need to think about that way ahead of time and say, okay, now I want to use the time library, so I need to include that in my library operating system. And then, I'm also gonna need to use the disk, so I need to include the disk driver. And because there's really no OS kernel in a scenario like that, you need to include all these. I suppose they're called kernel modules. And I think there's significant, I say, business value to be created there if someone makes that whole process much easier.
I think people are working on it, aren't they?
Sorry, go ahead.
I think people are working on that.
Yeah. I think I am aware of one or two companies that are working on it.
The reason, the interesting thing about unikernels, as I understand it, and the thing that interests me about it, is that you can't log into the machine. That's the huge advantage.
Yeah.
So you could, leaving aside the kind of smallness, you could basically just drop off. If you just take out the login shells, then you're in the spirit, you aren't in exactly, in your most optimal unikernel, but you're certainly, in the spirit of what is good about a unikernel, i.e. that you can't log into it. It really is a kind of appliance type environment and not a general purpose operating system anymore.
Exactly. And okay, so I'm going to add to that, and I'm going to add to that by going off on another tangent.
Do it.
And,
please, go ahead.
Which seems to be the topic today.
It's always the topic.
Tangential discussions.
That's
Topic of the
podcast.
day.
Yeah,
Yeah.
number
Yes.
one vegetarian closure podcast going off on tangents.
Of course.
And thinking about deployment scenarios for the OCaml programs that I work on, so there's always the traditional, Docker setup where you build your program, your project in there, you deploy to, say, Kubernetes, or you deploy to a standalone server somewhere that you don't care about it. But a paradigm that I've been, I think, as of recently, been closely monitoring is the whole serverless paradigm. And you mentioned that unikernels as library operating systems, they take away the whole login shell and out of the equation. So you can say that a whole lot of security issues are mitigated by that. Another really interesting thing about unikernels that I see is because they don't have to include this very heavyweight Linux kernel in your program, and you're only selecting the modules, the kernel modules that you're running directly on top of the cloud hypervisor. You can just basically have a unikernel startup for every request that comes in, which makes scaling problems just go away very, very easily. So like if you have something that starts up in 20 to 50 milliseconds, you can afford to pay that price. I'm not saying for every request, but like for every 10 requests that come in, right? You degrade the one request, the experience of one request by 20 milliseconds or 50 milliseconds, and you can just spawn and kill. I was going to say machines, but they're not machines. You can spawn or kill unikernels in a way that at a granularity that is simply not in existence right now, except in the functions as a service kind of scenario. And
they're definitely cheating. Yeah.
Yeah, exactly. Yeah. And so this is where I think the tangent begins. Is I've been looking at this service called Now by this company called Zeit. It's zeit.co, and they have this service, and they just launched their 2.0 infrastructure.
2.0 thing. Yes. Yeah.
Which is basically embracing lambdas and AWS lambdas, so functions as a service all over.
Yeah.
And so in a lambda context, the way your I think code is run is I think at least in AWS is that they one lambda never serves request is never invoked concurrently. And so if you have two people invoking making a request to your server at the same time, they're going to be served by two different lambdas. So and so that's something that is really cool, which also removes the scalability problem in some ways. It does introduce, it's like any other engineering decision. It's a trade-off because now you're forced to structure your program in another way.
Yeah.
And so something that I recently built over the past week actually was this. So they have this the concept of this thing called builders, and a builder is something that builds the code that you upload to their platform and generates a lambda. And so I built this lambda that allows you to run any statically compiled binary in their lambda context, so their infrastructure. And so I've recently made an experiment of running a statically compiled OCaml server and AWS lambdas through the Zeit Now platform. And so that's kind of cheating as well. I understand that just a little bit.
So it uses like Node.js to invoke to start up this process then?
It does not. It uses Golang.
Oh yeah, okay.
But because I didn't want to pay
course.
the price of starting up Node.js.
Yeah,
just starts in 10 milliseconds or less.
Yeah,
And Node.js is like
okay.
60 or 80.
Yeah,
something.
yeah,
So if I'm going to introduce any kind of overhead,
yeah.
at least it should be little.
Okay. So it's the Go binary starting the OCaml binary.
The Go binary, yes. The Go Lambda is starting the OCaml server.
Yeah. Okay.
But Lambdas also, so I mentioned that you can have a Lambda serve 2 requests concurrently. However, what you can do is you can or this is entirely managed by the cloud provider. But what they do, I think AWS keeps your Lambda context hot. For
some
15 minutes.
Yeah.
So if you have 2 requests per second, right? You're always only going to have 2 Lambdas. For 15 minutes. At which point I think they die, and then 2 other come up. And so because OCaml static binaries, they start up really, really fast. You only pay the price of starting this server on the first invocation. And I could imagine a scenario where you have this cron job that runs, say, every second is just making one request to keep the Lambda hot or something. And that is something that I've been really excited about as of recently.
But this is a completely different way of building applications, right?
It is.
Because we are so much. I looked into Zeit before. They were like version 1 thing as well. Like cross cloud providing things and everything. I mean, it requires basically, I don't know, re-architecting the way that what you think is an application is, because you traditional ways that, okay, I have a database or I have something, I have a web front end or whatever, I'm going to deploy these things. But how coming back to your point that the cognitive load of coming from Clojure to, oh, there is a nice programming language and then static system that is helping me in understanding the system. Doesn't the same complexity apply to these kind of things? Because there is shit is like split into a million lambdas, and then now I need to think about how to interact between all this crap.
Yeah, I would agree that.
Yeah, because I was looking at, of course, I built some Lambda functions and especially for the ETL sort of jobs and everything. And at some point, I'm like, okay, I have to switch to step functions, because there is no easy way to orchestrate all this crap.
The data flows, yeah.
Yeah, exactly. So what kind of applications do you think are going to be, of course, I'm not going to, say that this is all crap, like it's not useful for anything.
Right.
But what kind of mental shift we need to use platforms like Zeit or Zeit? I don't know what you call that.
I don't think I can, or I'm most definitely certain that I can predict the future.
Yeah.
But,
no? Damn it. This is episode number 42.
Sorry,
I thought we had the answers.
Mate. Come on.
Yeah. Give us the answers.
But I think we've seen a lot of paradigm shifts and a lot of shifts in mentality over the. That's what computer science and especially computer engineering has been since its inception. Is thinking of new ways to react or to architect the application that we run, and it may be a little rough right now to think of lambdas entirely. But imagine a scenario where you do describe it, say, just put a new layer of indirection in it.
Yeah, of course. That solves every problem.
As one does every time. And that layer of indirection that I'm thinking about is, imagine that you're somehow writing your program in the traditional, familiar way that you're used to, and then you have this build process basically if the way you architected your application is a cyclic graph, for example. It takes that and it knows all the dependencies of everything in your program, and it can generate, say, 1,000 lambdas for the thing that you wrote in the traditional way, right? Yeah. And I can certainly imagine that someone who solves that problem would be instantly rich.
that will be rich, data make ions anyway.
Can I ask you the thing? I mean, I'm kind of like, I've been to Lambdas a couple of years ago, and then I'm kind of a bit bearish on them at the moment, to be totally honest. And the reason I'm a bit bearish on them is because I feel personally that they're a bit like an enterprise service bus, in the sense that there is a kind of magic hand in the back of all these Lambdas that is, is generating the events and doing the invocations. And so I don't like that. I don't like this sort of magic hand operating in the system. So this is why I'm kind of down on it. I think the concept of highly parallelized and distributed programming is totally awesome, but the Lambdas seem to me like they're not right. So,
I see. Yeah, I mean, I'm also. Everyone's entitled to their own opinion. I
want you to defend yours against mine.
I'm not saying I disagree or I agree. I actually, this is actually the first time that I've been messing with Lambdas. Right. So I really can't be considered an expert in the matter. So I'm gonna leave your opinion as you laid it out, because I really don't have a comeback for that.
Okay. No, I like the unikernel concepts though, because the unikernels are independent and they're
yeah. The way I've been thinking about Lambdas so far, as I've mentioned, I don't have I have zero to very little experience with them. Is only in the context where a Lambda is attached to what AWS calls the API gateway, which is they're invoked.
Yes.
Or the event that they receive is effectively an HTTP request.
Yeah.
And that is the only concept, the only context to which I've been exposed. So I can't really say anything else.
But in that situation, which I think is a very, very useful situation, any kind of network request is a very useful, you want to respond to that network request.
Mimics the use case of unikernels. And that's the way I've been thinking about them.
Yeah. But the nice thing about the unikernel HTTP request is you basically get, like you said, a full stack response, that's just impromptu, ad hoc generated. You haven't got all these fibers to go through and all these orchestration layers and all this other shit to go through. You just deploy your stuff somewhere. You make it essentially listen on an endpoint, and then the operating system just starts it on as needed. And that's the only glue that you need. Essentially something listening on a network socket that can call into your system, which I like the bare bones aspect of that.
Yeah, maybe Lambdas are a means to an end in a way that there's something that needs iteration, and they're not their final form. Who knows? Maybe in the future we'll have something like what you're describing that was an iteration on top of what Lambdas are now.
Yeah, I mean, I listened to the Mirage team, and that's what their kind of vision is. So
Yep. Yeah, that's definitely a very, very cool project.
Yeah.
Cool. So, before I think it's almost, almost 1 hour.
It's past an hour.
Pretty cool. Okay. So, I think we talked a lot about Clojure and then OCaml. So, what do you miss from, because you moved to OCaml, from Clojure?
Mm-hmm. What do I miss?
Yeah.
100% Datomic.
Awesome.
So I gave a talk at Clojure Tray.
About OCaml, right?
Yeah, in September.
Yeah, I saw that. Small FP. Yeah.
Yes, exactly. Not at Clojure Tray. A small FP Conf, which is the day before.
Yes.
And what I talked about was finding in OCaml what I was used to in Clojure. And I think the way I ended the talk is I really haven't found any suitable alternative for Datomic yet, even though GraphQL on top of a database gives you
kind of, sort of,
some part of the same experience.
Yeah.
Even though you really don't have the locality of, also in terms of data, but locality in terms of a database as part of your application, feeling like Datomic gives you.
Yeah.
And I really wish that someone writes, or I've
Or you?
thought about it. Yeah, exactly.
Yeah.
Preferably someone else, because I think it's a hard undertaking. Someone writes a Datomic client implementation in OCaml that I could, or even in C or C++, because you can bind to that, but that you can use.
I think there was some effort by Mozilla people to replicate or at least make Datomic using Rust, but it kind of died, I think.
What was that project's name? Mentat, maybe?
Yeah, something like that.
Yeah, I think that's dead in the war.
Yeah, but it disappeared pretty quickly, I think.
I don't. I think they killed it, but I haven't looked.
Anyway, so any final thoughts before we wrap up?
Okay, so I have one final thought.
Yes.
And, all right.
Since everyone seems to be entitled to their own opinion, I think I'm also entitled to mine. And so I think we've seen a lot of discussion recently about how the Clojure core team puts out features and how the community responds to that. And well, since I'm given the platform, I wanna give my opinion on that. And my opinion on that is that I feel like there's a lot of disconnect in expectations. And so I would attribute that the recent communication and let's call it maybe flame wars, maybe not that impactful. The recent anger from the community in relation to that is in my opinion attributed to a difference in expectations. In that people come to Clojure expecting it to be a community-run project in an open manner, and they need to accept that it's okay that Clojure is a project that is run inside Cognitect, tested at Cognitect, without any, okay, that's also not fair, but with little input from the community. And that needs to be okay. And if they like Clojure, they should keep using it with that in mind. And yeah, I felt like I needed to say that for a while. And
that makes sense. Yeah.
And so I would say this is defending Cognitect and the team that makes Clojure. But I also have the opinion that what I just said needs to be clearly communicated by the people that make Clojure and think about Clojure, so that people don't come to the language with the expectation that they can make any impactful difference in the shape of how the language is built and iterated on.
Yeah. I think that's. I think you put it very nicely. That is the mismatched expectations mostly, and that the trouble is that the people who come and then or the people who have been in the community for a long time already, they feel responsible for the language because they're invested in it.
Yeah,
I think that's where the fundamental friction is coming from.
Yeah, and I think a part of that also is that people that have I do not include myself in that group of people because I only came later to the language. But people that have been with Clojure since its beginning, they used the language at a point where it was pre 1.0, and Rich was actively soliciting feedback from the community. And then there was a point where that stopped happening, and so I think some people still have not conformed themselves with the way that the project is run now. That needs to happen, and that's going to happen sooner or later.
Yeah. I mean, I think I understand that most of the toxicity is on Twitter and everything. I mean, I don't read Twitter shit, so I don't care. I only
Right.
I only show up there to retweet some things or talk
Or
about some
Twitter
things that
is-
I'm doing, and it's like worst platform ever to have any kind of reasonable discussion.
Twitter
So-
is a terrible place to have opinions
Exactly. So
because Twitter inherently is a platform that makes you communicate in a concise manner, and speech that is very concise is often interpreted in many ways in which it wasn't initially predicted to be.
yeah.
Random fact of the day is when I think I read. I don't recall where I read this, and please feel free to fact check this.
We've got the team on that.
I read recently that one of the consequences of increasing of doubling the Twitter character limit was that people started saying please and thank you more.
That's nice.
Because in 140 characters, you just simply
can't
didn't
be
have
polite.
space to say please or thank you. So you just demanded stuff.
Yeah. I always thought that fuck you was shorter than please or thank you. So, it definitely works better.
I think it's also, the trouble here is that, every now and then, because I follow maybe Stuart Holloway and Alex and a couple of other people, and if I see something from them, then I have to understand the context. Like, what the fuck are these people are talking about? I don't know. There is something happening somewhere.
Yeah.
But the interesting part is that nobody's going to tweet like, oh my God, today I made an amazing program today.
Yeah, exactly.
And nobody's going to do that.
People, I
because-
would also encourage people, if again I'm given the platform, I would also encourage people to say good things about stuff more than they say bad things about stuff.
Exactly,
And
because there is enough bile out there. I mean, we have enough shit out there. We get it.
Exactly.
The
the
more
world is a terrible place. We get it.
The more we pile onto it. Because there is nobody saying, oh, today I deployed my project within half an hour without any problems or something. The terrible situation is that if there is, I think it's built into our I don't know, evolution or something, to warn each other about the impending doom rather than talking about, oh, there is a nice apple tree somewhere. Like, no, I'm not going to tell other people because I need all my apples, but there is a fucking, predator there. I'm going to shout to everybody. Like that's the tricky part, I think.
Yeah.
But I'm pretty sure there are significant amount of people who are actually enjoying and then having fun with the language. And
please
okay
don't,
with the way it is.
Do not get me wrong. I mean,
of course, yeah.
Clojure is a wonderful language that serves a wide variety of use cases. And if people are, comfortable with the trade-offs and the design decisions that have gone into Clojure, and they're comfortable with having because it has to be okay that some things are made by one company for everyone else, and the input that they request is not as big as other communities. And so if people are comfortable with that, they need to match their expectations to what the reality is and keep using it in a way that they want it.
Yeah. I think if you compare it to, it's interesting, isn't it, to compare it to other companies which do that. So I think an interesting example to me is like comparing Clojure and F# and Swift, let's say, because Microsoft are they make their things for themselves, and Apple make their things for themselves, and Cognitect make their things for themselves in the end. And other people benefit from it, and that's fine. I think the question is, like you say, about what is the basis? How Swift and F# and these other languages, I think, are more clear about what the basis of their change process is. I think the Clojure is not so clear, to be honest. I mean, and I think that's what I would say. The expectations have not been set properly.
They need to be set properly and clearly communicated. Because
I do agree with you.
Or maybe not, right? But if they are, that will probably lower the volume of complaints in the manner that they have been happening in the past, I think, few months.
Mhm.
Well, I think people like clarity, don't they? People like to
Exactly.
understand what the situation is because, like you say, I mean, expectations exist whether they're realistic or not. And it beholds. I think in the end, if you're producing something, then and you do expect other people to use it, then I think you should be clear about what the limit liability is. Because
Right.
if I
Yeah.
produce a car and people drive it, but then the wheels fall off, then people are like, yeah, but if you've had, whoa, mate, look, read the fine print. Wheels could fall off at any moment. Oh shit!
Exactly.
Yeah.
Yeah, there needs to be some kind of fine print here,
Yeah,
of
of course.
in my opinion.
Yeah.
Again.
Yeah.
But I agree with you. I mean, it's definitely always conflict is mostly about expectation mismatch. So
Yeah.
I think you've nailed that one. I think that's
Yeah,
100%. We can all agree on that.
Awesome.
Perfect. So I think
Harmony in episode 42.
exactly.
There
Finally,
you go.
we come to a stasis. Like a nice equilibrium. Thanks a lot, Antonio, for joining us.
Thank you
and
for having me.
It's been a pleasure to talk to you. And hopefully somebody will pick up Lumo. It's not going to be me. I hope not.
That's also fair.
I don't think I'm smart enough to pick up that level of.
I don't think it's
startup.
about the smarts, really.
Okay, then I have to poke you in Portugal, and then learn a couple of things from there. But it's a very mature thing to do. That you built a project and you're wishing it well, and then you're trying to you're reaching out to give it to a I don't know, next whatever we call succession.
Next in
Yeah.
line.
Yeah.
Whoever that may be.
Yeah.
Exactly. So hopefully you will ride the camel long enough, and then get back into closure, or maybe share your thoughts. And good luck with all the stuff. And just before we close, I have a small announcement about Dutch Closure Day. So we are going to this is like the 4th edition of it, and we do have a lot of fun there. I'm a co-organizer for this one. This next year it is going to happen on 6th of April on a Saturday in the center of Amsterdam. And this is the nice thing about the community. I mean, we have 150 spots available. It's a free event, so anybody can attend. And we have around 60 tickets gone already. I mean, we didn't even announce anything yet, and like there is no schedule or an agenda.
It's being announced right now.
Yeah.
Run to get yours.
Yes, get your free spot, and the call for proposals is open. So please submit your talk, whether it is beginner talk or if you want to take over Lumo and talk about Lumo. Please go ahead and check out our website closuredays.org. And this is a free conference, so we are also looking for sponsors. It's going to be very affordable conference. So we have 2 types of sponsorship. One is with 1,500 euro, and the other one is 5,000 euro. So we call it partner and then sponsor. So if you know somebody who knows somebody, or if you are interested in sponsoring, get in touch with Closure Days team. And I hope I'll see you there, and the whole Defen gang will be there with Ray and Wouter. So that's it from me. And again, thanks a lot, Antonio.
Yeah, thank you, Antonio. Stay
thank
on the
you for
line.
having me.
Don't jump off, even though we closed the channel down.
It was really great being here, and I actually have been trying to make it to Dutch Closure Day for I think 2 years, but it never happened. So I hope I'll be there this time.
You don't know, yeah. Third time is the charm.
Yeah.
Yes. Thanks a lot. That's it from us. And I think goodbye.
All right. something that didn't come up during the podcast though is that I'm an Emacs user. So I'm an Emacs. So yeah, take it, Ray.